A small clarification. Not null is one of the is a database constraint or just not null is like for example you want to create the primary key on one of the column. I need some multiple columns and not null also creating for the column something like that. I'm not clear that one. What exactly this not null is a key?
It is a database constraint. So database constraints are the different kind of properties which will help us to make sure that our data is accurate and clean kind of thing. So not null is one of the database constraint which will allow you to make sure that your column won't allow nulls. Okay, so if you don't want the nulls in that particular column, then you have to use the not null constraint. You need not to go for the primary key for all columns, right? You can't go because you have only one primary key on the given table. Let's take you have the employee table where you create the employee ID is the primary key, where it means it won't allow nulls, it won't allow duplicates, but you don't want SSN column should be null. You want every employee should have the SSN in US kind of thing. Then you can mention that one as a not null or the first name or last name. Last name, you should not the last name column. Always you must need the employee last name, right? Then you can mention that column as not null. So
and for example, if not null means in that particular column, it may having duplicate elements, correct? Duplicate values will be there.
It should not. One employee. Duplicates is fine. Duplicates is fine. Sorry. Not null is just a null opposite, right? So if you specify the not null means it won't allow nulls. That's it. If you want to duplicate records, anything unique key. Uniqueness is the one. Okay. The next key is foreign key. Foreign key. So the foreign key is to implement the referential integrity. Let's take, you are telling that I have a employee table where you have the employee ID and a name and his department information, DEPT information, department ID, something like that. You have another table where it's just the department information, DEPT ID and the name and something creation time, something like that. So here in this department table you have department 1 testing and 2 dev, something like that. When you have the employees, you are expecting the department ID, whatever you are entering in the employee table must be one of the key columns from here. Then you can define the department ID as a foreign key in this table, which will be reference to the department ID from the department table. That way you are ensuring the department ID columns, whatever you have in your table, are in the list of the department IDs you have in the department table, so that you won't get any anonymous. So basically here you're saying that I have the 2 departments. If the user by default some error, input error, if they give the department ID 10, you should not allow that one, because you have only 2 departments, department 1 and department 2. The same way, okay, you need to ensure that okay, you have the employee table, you have the all your employee information, you have the salary information where you have the employee ID and the salary ID, date, so and so. You can't process the salary for the person who is not in your list. Okay, so you can't process the salary for the person who is not in the table. Then you can make sure that the salary table employee ID is the foreign key relationship to the employee table employee ID, right? So to ensure the referential integrity means you are referencing to the other table, making sure that this value exists in the table. That is called the referential integrity. To enforce the referential integrity, we have a database constraint called foreign key. Is it clear? So what are all the situations? You can tell me, apart from the 2 scenarios what I mentioned, apart from that, can you tell me one foreign key situation where you can impose the foreign key?
For example, employee details and department details.
I already mentioned that one.
You already mentioned.
Tell me, if you understand clearly, tell me any another scenario, one scenario where you can impose the referential integrity.
And for example, if you wanted to confidentially want to maintain the data, and for that only we just mention the IDs from the one table, and another table we are maintaining the ID with respect to that particular details. For example, maybe in the banking something. For example, in the bank they want to maintain the confidential of the customer details, and something RBI whatever.
I'm giving the some more hint. I'm giving the some more hint. Let's take the sales table. Okay. In the sales table, what will I have? Order ID and the order date, product ID. Okay. I'm just giving the column names. You tell me which table, which column I can enforce the foreign key. Order ID.
Okay.
Order date, customer ID, product ID, and
product ID. Product ID can be the foreign key for order table. In order table, we should have a product ID for the order to be placed. So we'll have an order ID and product ID in the table.
Okay, that's good. Okay, so anything else in these 4 columns?
Yeah, but another table having the product details.
Sir, in customer table, customer ID can be the primary key, and here in order ID it can be the foreign key.
Yes, yes. So in this table we can make customer ID and product ID are the foreign keys, and the customer ID will reference to the customer table, and product ID will reference to the product table. Now the rules to the foreign key. Rules are the limitations. 1. The referencing column. The reference column should be either primary key or unique key. It need not to be only the primary key. In SQL Server, the foreign key which you reference to the primary table, that column can be a primary key on the table or a unique key on the table. Okay. Secondly, you can mention around 253 foreign keys. Foreign keys in a table. Third one, from 2016 onwards, this number 253 increased to 10,000. So just a very high level. The main important thing is the first column. The second thing, anyway, you won't move the beyond the limit. So the second and third is just to know, but the first one is the mandate to remember. For the foreign key, the reference column should be a primary key or a unique key in the table. Okay. So now the syntax. Let's take, I have my databases. Let me go here.
May I interrupt here for a minute?
Yes, Prashant.
So the reference column you're mentioning here is the department ID in the employee table or the department ID in the department table, which is the reference column you wrote,
so
right?
I'm going to be creating the foreign key on the employee table, right? And the employee table department ID referencing department ID in the department table. So here the department table called the primary table, primary or reference table, primary or reference table. Okay.
Right.
So the primary or the reference table. So here in this table, department table, the department ID should be a primary key or a unique key. It need not to be a primary key alone.
Okay.
So now let me create a first, as for this discussion, right? We have to have the first department table. So I'm going to create table DEPT TBL underscore DEPT. Tell me what could be the columns.
Department ID.
Department name.
Okay. So what could be the constraint over here?
It should not be null.
It should not be null.
And
so
primary key.
Yeah, primary key I can go.
And should not be null.
Yeah, if I mention the primary key, that's implicitly enforced not null.
Yes, yes.
Okay. So department name as of 50 something like that. Okay, that's enough. Okay. So when I create this one, this is fine enough. Sorry, it's created on the master DB. So 1 second. It's created on the master DB. It should not be. So I have to go ahead and change it to this one. And execute again.
Sir, if by mistake we create a table on master DB, does it impact our database?
Does it bad
Impact?
Impact? No, it won't.
Does it impact?
That won't impact, but you have to make sure that you need to take off that one from the DB, master DB.
Okay.
Okay. So then we need to create the employee.
So, one more question, sir.
Yeah.
So can we, like, by mistake we have added this column. So when we are deleting it, we are making a change to master database. So it is allowed?
I didn't get your question.
Sir, see, by mistake we have created this department table in master database right now.
Okay.
Now we have to go and delete it from the master database, right?
Yes.
So do we have the rights to make changes in master database?
Yes, in regular environment, you may not provide the access to the master database. Okay, as a developer, you didn't only operations of the DBOs has the access to the master database, and you may not have the access to the master database. But on your machine, you will have the access to your thing, right? So if you have the access to the master DB, which means if you are able to create the DB in that one, means you have that permission. You have the permission. So yeah, again, the permissions varies also. It doesn't mean always you can create, then you have to top. You can restrict the each DDL permissions, DML permissions, DCL permissions like that. Okay. So we can go ahead and drop from the table. I'm going to create here. The next one is, we already have the employee table, but I'm creating another employee table. Create table. TBL underscore EMP underscore. Generally, primary key is referenced by the PK and foreign key is referenced by FK. General notation, people you can easily understand, right? So here EMP ID, which is a small int, and which is the primary. The next one is name, which can first name, or I can make the name as varchar 50, which can be not null, and then I can have the DEPT ID. Okay, DEPT.
The name keyword in square brackets.
Yeah, so we can make that one in the bracket because that is the this one common keyword. So DEPT ID, which is varchar, sorry, it is integer, right? Or the small int. Now I need to specify this one as a foreign key. Then references which table? Okay, TBL underscore DEPT dot and DEPT ID. Okay, you can specify like this also. Okay, and one more thing, you can make the foreign key to the table which is in the same DB. You can't do the referential integrity across the DBs. Let's take, you have the department table in the another database or online store, and you have the employee table in the worldwide importers, you can't make a referential integrity between those two databases. You can make the differential integrity within the same database. Okay, and then that's it. Now if I try to insert the data into the TBL employee, insert into TBL underscore employee underscore FK values, I'm giving the employee ID 1, the name is test1, and the department ID is 1. Will succeeded or failure, or what will happen?
First we have to insert data into the department.
Yes, first we have to insert the data into the department table, otherwise it will fail. So here, see, the insert statement conflict with the foreign key constraint fk underscore so and so table occur in the database worldwide importers. The table DEPT column department ID is not exist. Okay, so we have to insert the record into the TBL underscore DEPT values 1 comma testing comma 2 comma dev.
Sir, one question, sir. In the primary key, not necessarily always having the foreign key.
What's your question? Primary key always necessary?
Is it having the reference to the foreign keys having or not necessary?
Those are the two different concepts, right? The primary key and the foreign key are the two different concepts. If you apply the primary key on a given column, which means you are trying to ensure that it's not a not null and it's not it should be unique. And if you are enforcing the foreign key, means you are trying to enforce the referential integrity. So in a given table, you can have the not nulls, you can have the primary keys, you can have the foreign keys, you can have the other constraints. It's not mandatory you should have all the constraints in a given table. It's not mandatory there is a order, nothing. Okay.
No. My question is the foreign key is always reference to only primary key or maybe unique key also.
That's what I mentioned here. My first point. I think you are following my sentence. It should be the primary key or unique key.
Okay.
That's fine. Okay, now
you missed the comma.
Yes.
Between the values.
Yes, you're right. Okay, now I have created two things and I can go back and check it. Right? So now if I'm trying to insert the second one here, to test2, this is fine too. Okay, now I can read the data, select star from TBL underscore DEPT, select star from TBL underscore employee foreign key. Right? So here is the data. First one is testing and development, first employee, and which is belongs to department 1, second employee which is belongs to second employee. Also I made it to department 4. I just changed it in the only employee, not to this one. Okay, that's fine. Okay, so this help you to understand the primary key and the foreign key. Any questions on the foreign key?
Earlier you were saying that a foreign key can exist on a primary key of the same table, right?
Yes, so this one, okay, this one the primary key, and you can add the foreign key also on the same column. You can also employee ID. Let's take that's a very rare scenario. If you see, that is you have the kind of a department table, employee table, and another table we have the department and employee. And you have the employee table, you have the department table. Another table you have the employee department table. In the another table, the first table, the primary key is employee ID, right? Employee table.
Right.
Department table, the primary key is department ID. But in the department and employee table, the primary key would be department ID and employee ID, right? So the combination, one employee should belongs to one department, or one employee can enroll to one class. He can have the multiple classes kind of things. Let's take the class and, instead of the department, class and the employee. One employee can attend for the more than one class. Then the employee and the class one, primary key is the employee and the course ID, something like that. Then the course ID is reference to the course table, employee ID reference to the employee table. You can have like that. So in that scenarios, you can.
Sir, in one table, like we can have one primary key or more than one.
Only one primary key. The primary key is only one.
Okay.
But it can be a combination of the more than one column.
Sir, then how we can define it like in syntax?
So in the syntax, suppose if you want to add the different table, let's take employee department. You already have the employee table where it has the employee is the primary key. Department table, employee is that one. Department has this one, right? So I'm just creating for the sake of the argument or the class purpose. I'm creating one table. Create table tbl underscore emp underscore dept. Okay. So here emp id. Okay, emp id integer. I can just mention this one as a not null or the unique. Okay, that's fine. And I can have the dept id, which is the int unique. Here I can specify the combinations like primary key of emp id comma dept id. Right. So here I can give this one as the reference. Sorry, I can give this one as a foreign key, right? Foreign key reference to tbl underscore reference enc, yes, references. Okay, tbl underscore emp underscore fk of emp id. Did I miss anything over here? Okay, so I can take off foreign key references tbl underscore dept of dept id. Why it is showing the
the data type shouldn't it match like small int?
Not the same. Oh yeah, it has to match with the same thing. Okay, right, the small int. Okay. See here, I'm creating the other table where this employee ID referencing to the other table, department ID is the foreign key, and the primary key again the combination of these two is the primary key, and again some created date time, update time, update date time. This is the syntax. You guys got it? So
one table having only one primary
yes,
key.
I have to put this one end. Okay, yeah. What is the question?
One table having only one primary key, correct?
Yes, we have the only one primary key here, right? But the primary key can be combination of more than one column.
Comma is missing after date time.
Pardon? No, that's,
no, I thought
that's the last column. That's the last.
Oh, okay.
Yeah, then it's not required.
So what exactly this means? What exactly this employee ID and department ID can represent as the primary key, correct?
Yes, the combination is the primary key. So one employee can be associated to more than one department in this scenario. Instead of department, you can read this one as a course. One employee can associate to more than one course. I can take the SQL course, I can take the .NET course, I can take another one, right? So the course table is there, employee table is there. Course and employee is another table. Clear, guys?
What I'm asking is the employee ID, department ID is in only one table, correct? TBL underscore EMP dot department ID in the table only, correct? But both the tables is Yeah, this is one table, and the employee ID and department ID having the constraint both having the primary key.
The combination of employee ID and department ID is the primary key here in this table. So you can specify 1 and 2. Let's take the 1 and 2, and you can't specify the another record with 1 and 2. You can create 1 with 3, 1 with 4.
Sorry for interrupt. You mean that we cannot specify the column primary key column 1 and primary key, column 2 primary key we cannot specify separately?
No.
But we combination.
No, you can't specify. You can't specify the employee ID primary key, department ID primary key. If you want to maintain the combination as the primary key, you have to specify primary key within the braces. What are the combination? If you want to specify only employee ID is the primary key, then you can write as the primary key over there.
So what if, for example, if you mention the combination of this employee ID and department as the primary key, what exactly the particular table is understanding?
Data. Let me try to insert some data. Insert into TBL underscore EMP department. Okay, let's take values. I have the employees. If you before to this one, let's see. I have the select start from TBL underscore DEPT. Select start from TBL underscore employee FK. So if I run these two, okay guys, so I have the test 2 records in the department, 2 employees in the employee table. Then in the table employee department, I can give employee ID is 1 and department ID is 1, and the created time is get date and my update time is get date. This is fine. Okay, so this is fine. Now if I want to give the same 1 if I trying to insert the same record again, it will fail because the primary key constraint is telling that I can't insert the combination, duplicate combination 1 but I can insert 1 2. Here these 2 records, right? See, and I can specify the 2 2, but I can't specify 2 2 again. Now if I read the table, select star from TBL underscore EMP DEPT, employee 1 with department 1 I can enter, employee 1 with department 2 I can enter. If you see the only employee ID column, I have the duplicates, means because I didn't specify the primary key on only employee ID. That's why it's allowed the duplicates over here. But if I see the department ID, I have the duplicates here because I didn't specify the primary key only on the department ID. I specify the department ID and the employee ID as the primary key. That's why it didn't allow me the 1 1 combination again or the 2 2 combination again. Is it clear?
That's what I understood. Just what you're saying, I want to understand in this way. That employee ID department 1 1, and this employee ID department in the next column it may not be accepted in the 1 1, but it can accept in the 1 2 or 1 3, something like that one.
That's what you are seeing over here. Okay, thank you. Let me move forward. So we talk about the foreign keys. Okay, the next database constraints are check constraints. The next database constraints are the check constraint. Check is the database constraint which will ensure the value in the column. The value in the column should meet some criteria. Let's take, you are giving the employee IDs. Hey, I want to make sure that my employee IDs start from 1000. I should not allow any employee ID less than 1000. Or if I give the salary, the minimum salary in the table should be greater than 10,000. If you have some kind of rules, check constraints, you can specify those things. Or if you want to give the some value, so all the not null, those things, just whether value could be duplicates or not duplicate, null or not null, kind of things. Here the check constraints is enforcing the rule. It's a kind of a business logic. You are making sure that, hey, my employee ID start from 10,000 only. Then you can specify a constraint, check constraint on your table. Let's take, let me drop the TBL EMPFK. Okay, right. So, or I can create some other table just for our discussion purposes. Create table PBL underscore EMP underscore check. CHECK check. EMP ID, which is integer or small int. I'm trying to say, okay, a primary key and check of EMP ID, okay, greater than 20. I'm writing my employee ID should be greater than 20. Then the EMP name, we are calculating. If I run this one, okay, it succeeded. Now insert into TBL underscore EMP check values 1 comma test1. See, insert statement conflict with the check constraint. The conflict occurred on the so-and-so table column employee ID, because we have the constraint saying that, hey, it should be greater than 20. But if I specify 20 and run it, this is fine. Oh, greater than 20, right? The 20 is greater than 20? No, 21. Okay, which is good. Now if I try to insert, let me drop this table. Okay, let me drop this table. Drop table. If I want to drop a table, drop table, table name. Okay. So what I'm going to do here is I'm dropping the table and creating the table again, but I'm taking away the primary key. I'm not going to specify the primary key. So when I create the table back again if I give the whatever the value I have here, it would fail if I give the less than 20 with the check constraint. I'm giving the 21. Okay, this is good. Next one is I'm giving some null value, null test2, which means I don't have the employee ID yet created for this employee.
It's accepted.
It's accepted. Why? It's accepted
because that is it's accepted because
it's not a primary key, and
but the check constraint is there, right? It's not a primary key, that's why it's accepted. But the check constraint, it should be greater than 20, right? So
yeah.
The rule
but the null is unknown, sir. Like,
yes, null is unknown, right? The check constraint will check whether it is a false or not. It won't check whether it's a true or not. Check constraints will check the condition is false or not. Okay, is a null greater than 20 is unknown. It's not the false. It's not the false. As it is not the false, it is accepting. Okay, so if it is false, it won't accept. So if you give the 1 greater than 20, false, then it won't allow. So the point to remember over here is check constraint will look into false output. Validate against the false constraint, I can say.
So you're saying it evaluates only for true and unknown cases?
Yes. So
I mean,
if it is false,
it validates true and
yes.
Okay. Yeah.
If it is false, it won't accept. So it's a true and unknown, both are the acceptable here. Only if the statement returns to the false, then it won't allow. Okay. These are the database constraints, which means to using these database constraints, you can make sure that your data is accurate some extent, right? So you can make sure that you avoid the nulls, you avoid the unique duplicate records, you avoid the some business rules over here. You are enforcing some business rules, you are enforcing some referential integrity. Any questions over here? Okay.
Can we give one null in another record?
Pardon?
Can we give one more null in another record?
Yes, it can. It's fine. Yeah, okay. Because it's not the unique constraint. It's not the primary key constraint. If it is a unique constraint, it won't allow. Right? That's fine. Okay. So the next concept is variables. Next concept is the variables. So anyone knows about the variables? What is a variable, as you know?
It's a memory space to store any data.
Good. Memory space.
Which is varying.
Yeah. Data. Which is varying. Okay. Which is varying. That's good. That's quite enough. Okay. So basically, the variables to hold the value, like the temporary table, right? It's to hold the result set. But the variables are the scalar variables or the tabular variables. We have the two types of the variables. Either it could be a scalar variable or a tabular variable. So if the variable hold the value of a scalar data type, like the integers, all numeric data types, character data types, other than the table data type, if it is a hold, then it's a scalar variable. If it is hold the more table valued information, then it's a table variable. Let's take how to define it variables in the SQL Server. So to define the variables in the SQL Server, you need to specify declare is the command. Declare, and the variable name start with the ampersand. Sorry, at the rate. Variable name start with the at the rate. Okay, I am going to be hold something called year. At the rate year. I want to hold a year value in a particular variable so that I can use that variable whenever I want to make dynamic my queries, or use the same query for the different years. I have a query which will return the all the sales records for a given year. Okay, today I got the question saying that, hey, can you give me the sales record for 2013? Tomorrow you ask me, can you give me the sales record for 2014? Can you give me the sales record for 2015? The question is same, just the year value is changing. Then you need not to write your query again and again. You can just switch the variable value. So you can pass the different variables to your query, make sure that your queries are dynamic. You can reuse your queries again and again. You need not to rewrite. So that is the main purpose of the variables, right? So to declare the variables, declare variable and data type. Data type, let's take integer. If you want to specify a value for this variable, you can use equal to 2013 like this. I have declared a variable. I want to read the data what I have in my variable. I can select a variable. You can't just simply execute this one, right? If I execute select at the rate variable, it don't know what is the at the rate variable means. So I have to select both commands. I have to select both commands and execute. See, 2013. If I change this one to 2015, if I change this one to 2017, so whatever the value I am assigning, so this is called the default assignment. So the value you can just assign to a particular variable by default. So, or during the flow, if you want to set the another value, okay, initially I set the 2017, later I want to set to 2018. So then I can set, there is a keyword called set, at the rate year is equal to 2018. Then if I select again, see, if I execute all these commands, first I have the value of 2017, then I set for 2018, so my value is 2018, right?
So what's the scope of the variable here? What is it? The scope of this variable is
go ahead.
No, is it transaction? I mean, what is the key word we use for, like earlier we used like for a session for a connection, right? But the scope is
so this one, the scope of variable also a session only. So if you go to the other window, it won't identify the select. In other words, it's not only the session also, it's a particular to that query. See, it's a kind of a one execution.
Yeah, like earlier when you declared the variable and you selected, but selected is another batch, like I don't know if I'm talking it right.
Yes.
So when you didn't select them together, it didn't even get the value, right?
Exactly.
So the scope is called?
It's a kind of a batch you can call, or you can call kind of a single query. It's all a single query.
Okay.
It's come under a single query.
Okay.
Yeah, batch you can specify.
Okay.
Yeah.
So it applies to one execution. When you do the execute, and it applies to that session only, right?
It's not the session. Yeah, you can say the one execution or one batch. One batch. Okay. Yeah. Okay. So basically, you are executing this one as the batch statements. It has the multiple statements over here, right? So you are executing. So it's a one execution or a batch. The scope of the variable is. So now you can declare a variable, and you can assign a variable, and you can set the value, reset the value. You can again select. Another way to do it, year is equal to @year plus 1. See, so if I do like this,
you have to select @year again.
yeah, it is assigned now. It is assigned. Select @year. Okay, so if I write here, there are multiple things. See, to assign a value, we are doing this is the one of the assignment. Okay, assign value. Here the set value, which is nothing but the assign the value, right? Set value or the assign value. Here also we are assigning the value, assigning or setting the value. So to set the value to a variable, there are multiple options. One is by using the default declaration.
We are using selector here, year plus year plus 1.
So you can set a value like this also. Instead of using the select keyword, you can use the select keyword to set the value also. Or you can use the set statement, or you can by default equal to assignment also. So these are the three different ways. Okay. And if you want to just print the messages, so if you see here the print is another keyword only within the SSMS query window. Don't use the prints in your queries in application queries. Don't. Okay. Print @year. Select year, print year. See here, when I print it, it won't show in the result set, but in the messages it's shown up. If I want to, I have the couple of lines of the code. Then I want to see what is my value during this point of time. At this point of time, what is my value? What I can do, I can select or I can print it. But if I select it, that will be turned as a result set. So if you are assigning these values to the some other result set from the application, that would capture just the print value, right? It's not the actual result set what you want to share. So it's not suggested to use the select. You can just use the print, so that in the messages, the log messages what you created, you can get that print value. So to see the result of a variable, the things are, you can use the select or the print. So it is display a variable value.
Can you repeat the advantage of using print, or the purpose of using print?
Yes.
Can you repeat that again?
Yes, I will. So suppose if you use, let's assume you have the 5 queries simultaneously executing in a stored processor or anywhere. So there is a workflow. You are executing one by one query. You want to know what is your results intermediately after executing the 2 queries or performing the 2 queries. What is the value of a particular variable? Then if you do the select variable, that will be turned as a result set. If it is turned as a result set, means You are passing the values to some applications. The data sets are reading the results from the stored procedure or something. That selected value will be passed. So only single column will be passed. That is not your actual intention to pass the value result set, right? Your result set should be the end of the statement, could be. So, but your intention is you just want to see the value what you have. So if you use the print statement, in the console it will just type it. It is not written as a result set. Result sets are the different, messages are the different. If you see messages, for each statement execution, it will display some message for you. One row affected. When you inserted, one row affected. When you selected, one row affected. That is the message for the tracking purpose.
Sir, these messages are actually the log generated by the database whenever we are like working on the database.
Yes. The messages kind of a log information kind of things. The results is the result set which can be consumed by other applications. Okay. So the print is kind of a message. Select is a result set.
Yeah, got it. Thank you.
Yeah, sure. So now we understand we have the variable, right? Now let me write a query. Okay. Select star from sales dot orders. Where I have the table. I don't have anything here. Maybe sales dot orders where something date. Do I have any date column in this order lines? I have the dates, right? Order line. Order lines where order date, year of order date is equal to 2013. If I run this one, I think I don't have this column. Let me have a look. Tables, order lines.
I think there is some transaction date or something.
There is last edit by quantity unit by picking completed when last edit. Okay, I can go for the other table. Orders where I have the order date, so I can go by the order date. Okay. Suppose if I run this one, this is static. Okay, you are reading the data for the 2013. Suppose if you want to write the 2014, you have to change your query, right? So 2015. So instead of that one, you can use the variable to hold the value. You will try to understand the base advantage of the variables after the functions and the procedures, but functions and the procedures. I'm just giving the heads up over here. So you can execute all these things. Now I have the 2017, later I set to 2018, then I set to 2019, and if I query want to change this one, I can just use the year instead of the hard-coded value. Now if you see here, I don't have any data set because my year value is 2019. Let me comment it out this one. I'm not going to be setting all, I'm not going to be assigning. See, I don't have any 2017 data also. Sorry guys. Okay, let me see 2013 data. 2013 data. If I just change here, I'm not touching my query. I'm not touching my select query. If I have the joins and all these things, I'm not touching my query. I'm just changing the variable value. See, all the variables based upon the data is changing, right? That is the purpose of the variables. And if you want to use, I want to get the sum of the sales, sum of the count of orders for each year. I want to get count of order for each year. Then I can use count of 1 as number of orders, comma, I want to number of orders. So for the given year, whatever the year I have passed, I want to get the number of orders. So for the 2014, I have 21199. For 2015, this one, right? So you are reusing your code by passing one variable, which is nothing but a parameter. Okay. By using the variables, you are reusing your code for the purpose to do some computation. Here you are using the computation as the count of the records, right? So there is a functionality in the SQL Server, in the computer science also, there is a functionality called the functions. Functions are the subroutines or the block of the statements which can be used again and again to compute some computation. So the functions will return the value. So the functions will use to perform some operation, some computation, and functions will return the value, right? And functions will take the parameters. So you can write a function saying that, hey, get me the number of function name. I can give the function name as fn underscore something like that. Fn underscore get order count. Get order count. I can pass the year name. So if whenever I created a function get order count and I am passing the year name again and again, whatever the value I am passing, this function will return the value for me. You guys remember the aggregate functions? So min, right? Max. What the min max is doing? Or sum. These are all the function, aggregate functions. Aggregate functions means they are doing some computation for us. They are summing up the value. They are finding the maximum. They are finding the minimum. So in the backend, it is doing some work for us and returning the value. Exactly. So there is some system defined functions and you can define user defined functions also. So the functions, what you have, the aggregate functions and all these things are the system defined functions. We can create our own user defined functions also. The user defined functions in the SQL Server are divided into three categories. One is scalar functions. Another one is tabular function, table valued functions. Table valued functions. In the table valued functions, two types. One is inline table valued function. Another one is the multi-line table valued function. So in SQL Server, we have two types of functions, scalar valued functions and table valued functions. In the table valued functions, we have two types, inline table valued functions and multi-line table valued functions. The purpose of these functions is to perform some computation and return the value for us. Is it clear? What is the function? Why we use the function? Those are the two questions I'm answering over here. Sorry. So if you go to your database, there is a folder called programmability. In the programmability, if you expand, there is a folder called functions. If you expand the functions, you will find the table valued functions and scalar valued functions. So if you click on the table valued functions, you can see new inline table valued functions, new multi-line table valued function, and again the same way new scalar valued functions. So here it will give you the syntax or the skeleton or the template to create a function. Let's see the scalar valued functions first. If you right click on the new scalar valued functions. Okay, that will create a skeleton for you. So how would you create a function? I'm taking up all these things, not required for us to discuss. Okay, here if you see, a function definition is a create function name. So in our example, here we want to create a function. Sorry, here we want to create a function to get the order count, right? So our function name should be create function. You can give the function name here, fn underscore get order count. Then open parenthesis and close parenthesis. Between this one, you can add the parameters. So what are all the parameters you need to pass to your function? Let's take, I want to pass the year. For the given year, I want to identify what is the total order count. So I can give @ year. and the data type. Data type, it could be the int kind of thing. So I can give the whatever the parameters I want to pass here, the returns, and what is the value you are returning, what kind of data type, just the function data type you need to specify. You need not to specify any variable or anything over here. You just need to give the what is the value. So whenever I give the count of function, what is the output I will get? What data type I will get? Integer, or if it is a more records, big int, like that, right? So I can go for the integer for this point of time. So returns is the keyword. It must be okay. Returns int as, and here you need to give the code for this one. So the code is so these 2 lines, right? So here the code is, I already have the query. I'm just taking my query, whatever I have written. Select this one, right? Here return, what is the value I'm returning, right? So you can just return the result set of the function, or you can just give the return. Okay, so here, or you can give like this. Okay, I'm going to declare a variable which is going to be written for me. Declare, okay, at the rate count. I'm returning the count, which is integer data type. Okay, here the count of 1 I'm assigning to count function. The variable assignment I'm doing the count of 1, right? So return at the rate count. See here. So if you understand, we just created a function over here, a function which is taking the year as the input, and it is doing the select count of 1 for the given year, and I'm holding this the result set value into a variable called count, and I'm returning that count variable. Then whenever I executed this one, see, it is going to be executed in the worldwide importers. When I click executed, it created a function for me. Then if I go to my scalar valid functions, expand it, see, there is a function fn underscore get order count is there. So the parameters are here. There is no default value I have provided. So I have to pass the value always. Now I created a function. How would I use this function? How would I call this function? Select. Functions can be just, you already see, right? Or you have used the functions in the select statement. You can use the functions in the select statement. So select fn underscore get order count of. You can pass the variable, okay, 2013 like this.
I think two-part name should be it.
Schema name. Did I give the?
It's just DBO dot.
DBO dot. Yeah, schema name must be specified by the schema name. Okay, so just select 19,450. If I pass the 2014, 21,299. So 15, 23,329.
Sir?
Yes.
Why don't we see at count variable in the parameters under the parameters section?
At count? No, this is the parameter what you pass when you are calling. So you need not to pass the count, right? That is your local computation variable. So you are passing only the year value. If you pass the year value, that will return the count for you. So the returning values you need not to specify in the parameters, parentheses on the top. These are the parameters, input parameters, what you are passing to here. Okay, the count is the intermediate variable where you are holding the count of the records and returning that count here. Is it clear?
Okay. Yeah, okay.
And while calling the functions, you can just simply select this function name. This is the scalar value function, which means you are just created, you are returning the single value, right? Then the table valued functions. Let's take, I want to pass the count comma year number also, year name also. I want to get my count and year name. Can I get the year name here? No, it's not possible. I can't pass the more than one column here, right? It is a one result set value because it returns only integer. I can't pass the integer comma integer or like that. So if you want to pass the more than one column, you want to returns the more than one column. Sorry, you want to return the more than one column. You have to create the table valued function. You have to create a table value. Table is contains more than one column. That's simple, right? So if you want to return the more than one column, you have to use a table valued function. Let's assume I'm going to create a new inline table valued function. Okay, the same thing. I don't need all these things. I'm just taking off. Create function name. I'm giving the same function name like fn underscore get order count underscore year, something like that. Okay, and the parameters, you can pass the only one parameter year. You can pass here @year integer returns a table. Okay, it returns a table, and the return value you need to write over here, right? The select statement. So whatever the select statement here I have, you can just copy and change here. Select count of 1 as count, num row count or order count, comma year of order date or the @year, right? @year as year name. So here I am getting the order count and the year name for the past year. Is it clear? So my function create function name here also returns. Here what we are returning a table as in the return statement. For the scalar value you write a statement and return the value. Here,
sir, in this,
yeah.
Sir, in this return table, we don't have beginning end.
Begin and end is okay. Begin and end is it's not the you are writing all your query within the return parenthesis. So there is no begin and end over here. If you want to write the more than one statement here and finally try to get the things, you can write the begin and end here. Okay, that's not an issue. Begin. Okay. So begin end will identify the block of the statement, block of the information. So you don't need over here in this table valued function, inline table valued function, especially because you are writing the definition of the table, the definition of the result set within this return statement, right? So this is the inline table valued function means you are writing the code within the return statement to what is the result set value. Now if I execute this one, is done. Now I can't write select this function name. If I expand this function name, so order count of year, right? So here 2013. This is wrong because this is not the scalar valued function where you can read with the direct as a column. Okay, you have to write as a, how would you read the data from the table? Star from. You have to read star from like this. See, as it is returning the data as a table format, you have to read as a table format. Select star from table name. The table name is the function name with the parameter. Suppose if I pass the 2014, like this. If you pass the 2015, like this. Okay, that is the inline table valued function. Any question over here? So while reading the data here, you need to use as the from keyword. In the scalar value, you can just read as a one of the column as a normal system defined functions. You can use as the same way as the system defined functions. Any questions? Is it clear? Okay.
Yes.
Next one is multi-line table valued function. Multi-line statement, multi-statement table value or multi-line. So whenever you mention the multi-statement means you want to perform some more than one query executions and all these things. Finally, you are designing a table. So your result set statement is not like this, or here it is implicit. If you see here, you are not defining a table structure here. You are just giving the select query. Based upon the select query, it is treating, it has the two columns. If you change your select query here, adding the another order date, right? So if I alter, if you want to change my definition of the function, I have to use the alter command. Alter, if I already there. So I altered the function. Oh, it's I have used the count function and the this one, right? So that's why it's asking the group by. Let me give min of order dates. Let's take for simplicity purpose. If I alter the statement, oh, name, min order name. Oh, sorry, it's as year name is came here actually. So while I'm writing, so my point here is in the inline table valued functions, you are not defining the table structure. You are just giving the result set. Based upon the result set, it is identifying what is that, how many columns it has, what data types it has. The result set is defining, right? But if you want to specify a particular table structure, I want these columns only. You are imposing, and you are trying to get the specific order of your table. Then you can go for the multi-line, multi-value table valued functions. So here, sorry, new multi-line table valued function. Here, create function name. Let's take fn underscore get order count underscore multi underscore multi. That's like, okay. Then the same thing I can give here at the rate here as integer. Here, if you see here, it is asking you to returns a table variable. A table variable. You need to write, okay, let's take get order count as a table which contains the two columns. First one is the year. First one is the year name, let's take, which is integer. Next one is the count, row count or order count, which is integer. So you define your table over here. Then fill the table variable with the rows you want to fill. So while you are trying to insert the values to this order count, right? So basically, you want to, now you have a table variable and you want to set the values. For the scalar variables, we will use the select statement or the set statement to set the values, right? So here, in the same as like this, okay. Insert into at the rate get order count, select the same query what I have. I don't need this. First one is the year name, so I have to make sure that in order. Select as year name, count as this one. Let's assume if I have the another column here, it will fail. If I try to do the same thing, it would fail. Let me execute and show you. Number of the columns you specified and what you have is not matching. Here you have the 2 columns and your select query is specifying the 3 columns. That's why it's not working. So if I take off the order name, just insert into table, select first year name and order count for this one. Then I'm just selecting, then execute. See, command executed successfully. Then the same way as inline table valid function, I can simply select this one. Right? Sorry, this is the previous function. This function name is multi. Year name and order count. So the difference between the inline and the multi is, in inline you need not to specify the table structure. In the multi you have to specify the table variable with the structure and you have to fill that table variable, then return that table variable. Okay, so here you have to write all your business logic over here only, right? Here you can specify all your execution, at the end you can fill into that one. That is the main advantage of this one. And you can restrict what kind of columns you can have from the table structure, whatever you have specified over here. Is it clear? So we have 3 types of functions, 2 types of functions, scalar and table. In the table we have 2 types. I will upload the scripts. Please go ahead and try to this one and write a function. If I pass the month number, I want the month name written out. If I pass the 1, my function should return the January. If I pass the 5, my function should return May. Is it clear? I have an exercise for you guys. Okay, so whenever I pass the number, I want to return the month number, month name. Okay, and you can give the days differences. I pass the minimum date and maximum date, 2 dates. You need to return me number of days between those 2 days. If I pass the March 1st and March 9th, you should return the 9. Okay, write down these 2 functions. First function, I will pass the month number, you should return the month name. Second function, I will pass the 2 dates. You need to get me the date difference between those 2 days. Okay. Okay, thank you. And yeah, feel free to register that next sessions, guys, and